Today we are going to do Ohm's law experiment. Here in the pic you can see the circuit diagram of the Ohm's law. First we have ammeter, voltmeter, the resistance of whose resistance we have to calculate a wire. Then we have a key for on and off. This is the battery. We have a rheostat. Now the connection you can see as in the figure. The positive pole of the battery is connected to the positive pole of the voltmeter. The negative of the voltmeter is connected to the positive of the ammeter. The negative of the ammeter is connected to the one terminal of the rheostat. Another terminal of the rheostat is connected to the negative pole of the battery. And here you can see a wire whose resistance we have to calculate. And this is connected in parallel to the voltmeter. Now, object verification of Ohm's law. Here the apparatus we have used, as I have told you earlier only, like ammeter, voltmeter, battery, rheostat, key, and finally the resistor. Now, according to the Ohm's law, the current flowing through a conductor is directly proportional to the potential difference across its end, provided the physical conditions of the conductor. Physical conditions like length, area of cross section, material of the conductor and temperature should remain constant, right? So here we can say that V is directly proportional to I or V is equal to IR. Here R is a proportionality constant and we can say it as or name it as a resistance. So the formula becomes V is equal to IR. Now let's start doing the practical. Connect the resistor, battery, key, rheostat, ammeter and all the apparatus in series as per the given diagram of the circuit. Note down the least count of ammeter and voltmeter. Now the meaning of least count is the minimum value you can measure with the help of any apparatus. Like if we take an example of a meter scale, we have the 10 divisions in 1 centimeter. So 1 centimeter in 10 division means 1 division is equal to 1 millimeter. So 1 millimeter is the least count of the scale. Means with the help of the scale you can measure a minimum distance that is of or minimum length that is of 1 millimeter, right? So 1 millimeter becomes the least count of the meter scale. Similarly, we are going to calculate the least count for the apparatus like your ammeter. Here you can see the range of the ammeter is from 0 to 100. This is in milliampere. Now here you can see the first reading is 0, the second reading is 20. So how to calculate the least count? 20 minus 0 upon number of division, and here the number of divisions are 10. So 20 by 10 becomes 2 milliampere, that is 2 into 10's power minus 3 ampere, right? Now similarly we are going to calculate the least count of the voltmeter. Here you can see the range of the voltmeter is 0 to 5 volt. First reading is 0, second is 1. So now the least count is 1 minus 0 upon 10, that is 0.1 volt. Got it? So here we have already calculated the least count of the voltmeter and ammeter. This I have already calculated on a paper, least count of ammeter and least count of voltmeter. Now we are going to calculate the first reading of the experiment. Now what I do is I turn on the key, current start flowing through the circuit. Now first reading I am going to calculate here, as you can see. Now simply I increase the value of the resistance, right? So we know that when the value of the resistance increases, the current always decreases, as resistance always offer the obstacle in the path of current, right? So here you can see I have fixed up the value of the current at 10 milliampere. So first reading of the ammeter I have taken 10 milliampere. Now move to the voltmeter. Here you can see the reading of the voltmeter. Here it is. In between 0 and 1 means 5 volt. Now children, this we can calculate either directly from the apparatus or we can use the least count also. But according to me, I think least count if you use, that will give you the appropriate value, right? So here with the help of the least count, here the first reading is 0, 0 plus the number of division is your 5. You can see the needle is on the 5th division into the least count. So it becomes 0 plus number of division is 5 and the least count for the voltmeter is 0.1 volt. So the value becomes 0.5 volt. Either you can use the least count or you can take the reading directly from the apparatus. Now children, here you can see I have calculated the reading of the voltmeter 0.5 volt. 0 plus number of division into least count. 0 is the first reading plus number of division is 5 into the least count is 0.1, so it becomes 0.5 volt. So here the corresponding value for the ammeter is 0.5 volt. That is the voltmeter we have calculated, right? So now I have to calculate the resistance. R is equal to V upon I. V is 0.5 volt. Second reading we have the ammeter reading is 10 milliampere, that is 10 into 10 power minus 3, so it becomes 50 ohm. Similarly, we are going to calculate the second reading. Here again, if I increase the value of the resistor, current is 20 milliampere, corresponding to this is 1 volt. So here I have taken the reading 20 milliampere. I have noted down the reading, corresponding to this is 1 volt. Again I have calculated the value for the resistance. V upon I, 1 upon 20 into 10 power minus 3 becomes 50 ohm. So here you can see that the value of the resistance is coming constant. Similarly, we can calculate more readings. Potential difference at the ends of the conductor remain directly proportional to the current flowing through it. Therefore, value of R is constant, means it remains same every time. Now, few precautions we have to take while doing this experiment is, first, take the reading quickly, otherwise the temperature of the conductor will increase and the resistance of the conductor will be affected. You have to remember one more thing, that is the voltmeter should be connected in parallel. The resistance of rheostat which is used in circuit should be low. Thank you so much.